Okay, let me tell you what I want to do today, or at least what I want to do in this video, is I want to kind of wrap up the statistically describing a data set. So what we're working with right here is there's some larger population, and use your imagination for that. If you want to think about something, let's just say it's ACT scores for all college students in Ohio. And we decided to go in and take a sample. So we want a smaller segment of this. And I'm going to call this an SRS, which is a simple random sample. Now, when I have my simple random sample, as I talked about in the last video, I may call this X, or I may call it ACT, but I'm going to give my variable a particular name, okay? And generically I can call it X, or I can give it a name more specific to what we collected, and be real creative here and call it ACT. Well, first student got a 24, the next one got an 18, the next one got a 27, and so on and so forth. So we end up with a lot of ACT scores that we select as a simple random sample from a larger population. Well, the very first thing we would want to do in statistics is to look at this, all these numbers, and statistically describe our sample. And statistically describe our sample is just a big old fancy way of just saying that we want to look at important characteristics. Okay. Now, in statistically describing our sample, we're going to want to accomplish a couple of things. The first thing we're going to want to do is we're going to want to make the appropriate numerical summaries. And as we saw in the previous video, the numerical summaries that we want to be able to make is we want to be able to make an appropriate center statement, and we want to be able to make an appropriate spread statement. The center statement gives us kind of a typical score. So something we may use as a center statement would be the mean. So if I find the mean or the average of these numbers, what I'm getting is I'm getting a typical score. I may get an ACT score as my mean that no one scored that particular value, but it's just kind of an average score. The spread gives me a level of consistency. How consistent are my data? How much variability is there in our data? The second thing that I'm going to want to do today, more specific to this video, is to introduce you to graphical summaries. And guys, graphical summaries, graphs and tables and charts and things like that are extremely important because they give us pictures of our data, and once we learn what these pictures tell us, we can look for important characteristics and patterns of our data. So that's something that's to be learned later, and it's my responsibility to teach that to you. There's two things I want to look at today. I want to teach you probably far more than you ever cared to know about a histogram. And I want to teach you far more than you ever cared to know about a box plot. Okay? So that's kind of what's on the agenda. And so in my feeling, at least, the best thing to do is let's start with some data. Now, I don't have any ACT scores, but what I do have is I have a data set that I've uploaded to Blackboard called body fat. So let me get out of here. Get out of this right here and minimize this. And so this data set that I have uploaded to let me bring this over just a little bit. Okay, and let me bring this over a little bit where we can get a better picture. Okay, perfect. Now, gang, the first thing I want to do is I want to review what we did in the previous video. So what I would do is I'd want to enter my data. So I'm going to go to Stat. I'm going to go to Edit. If you remember from the video that I just put up, the first thing we'd want to do is clear out our old data. And the easiest way to do that is to go up and highlight the L1 and go Clear, Enter. That'll keep the list, but it will delete the heading of L1. So now I want to just type my data in. I thought seriously about going ahead and having this done, but having taught this class over 100 times over the past 21 years, I have noticed that sometimes students have trouble entering data. So I'm going to do that with you. All right, kind of boring. 12.9, 21.7. I've always found it's easier to enter data if somebody reads it to you. 27.1, that's kind of annoying that those are that close. That would be kind of someplace where we get a random error. So 25.4, 21.3, 19.3. Sometimes the Kentucky accent just slips out when it shouldn't. 25.4. 27.2, 11.7, 12.8, 23.9, or 23.9, 22.6. Guys, you'll have to bear with me. I put up about with my graduate level classes, my undergrad classes, I put up about 10 videos a week. When I get bored, I start getting kind of stupid. So, not that I get bored teaching stats. I love teaching stats, but sometimes I just get bored and do stupid stuff. All right, gang, I need to scroll down a little bit so I can see the rest of the information. So it looks like I've got a 21.1. Now, the first thing I would want to do once I get all my data in is enter it. Is I want to go up to the next line. So I've got 19 numbers entered. So I'm going to go into my Excel file and I'm going to go full screen here. You can tell I've got Mac, so if you don't have Mac. And I can see right now that I have 21, but my first one is for my heading. It's for so I've got some data missing somewhere. And actually, to be honest with you, I did that on purpose just to show you, keep you on your heels. Now, where is my, I should have 20 numbers and I don't. So let's exit full screen and go back over and see if we can determine where the missing information is. So my last number is 21.1. I'm just going to start from the bottom. And then I should have a 14.8. 25.4, 22.6, 23.9, 12.8, 17.8, so I have a typo. Glad I found that. And I'm missing an 11.7. So guys, this 11.7 right here is missing from my data set because I jumped from 17.8 to 27.2. Now, I don't need to have the 11.7 necessarily in the same place that it is on the data set as it is in the Excel file. Shoot. I can add that anywhere. So I'm going to go down to the bottom and I'm going to add this 11.7 because the calculator is pretty smart. It can figure out that it doesn't matter where the 11.7 is put in. It's going to treat as a comprehensive data set. Now, for the time being, what I want to do with this Excel file is I'm going to do full screen, and then I'm going to put that up there and get it out of the way. Now, let's make this a little larger. So, guys, let's go back and talk about the things that we would like to be able to find and be able to interpret. So, the measures of center that we talked about the other day are the mean, the median. And guys, I'm going to throw an extra one in on you today called the mode. And the mode is the number that occurs the most. Now, sometimes there's no repeated data, and I assume that's probably what's going to happen here. So the mode is something is just the number that that occurs the most. I've examined a lot of ACT scores at Shawnee State, and it seems like the mode is usually 21 or 22. It seems like most students come in with a 21 or well, not most students, but 21 or 22 is the ACT score that is repeated the most for entering freshman year in, year out. We don't see many 30s, although we do have 30s. In fact, I've seen 34s and 35s at Shawnee, but we don't see those most, or see them very much. So I always remember mode as just occurs the most. I don't know why, but OM, EM is exact middle, and AM is just the average or the mean. So it's something that I've come up with as a goofy kind of prompt. All right, gang, spread. We want to be able to look at the range. We want to look at Q1. We want to find Q3. We want to be able to find the IQR. And we want to find the standard deviation. And I like to be able to find the variance. All right, so let's do this. It's really easy when we have the calculator. So I'm going to bring up our data here, and again we've got it typed into L1. So I'm going to go Stat, go over to Calc, go one variable Stats, and the default here is L1, so that's what I need. Frequency list, we'll talk about that a little later today, or quite possibly even in the next video. So I'm going to come down here, calculate, and go for it. So gang, the mean here is 20.195. We're going to round that to two places. So guys, this 19 will round to a 20 to give us 20.20. And I'm going to write that over here on my sheet of paper. I'll tell you what might kind of be semi-handy is for you to be able to see this as I'm writing. I don't know. You can keep me posted if that matters at all. Well, I don't like the way that is, but well, you can see it over here. Okay, so that's fine. So the SX, the 5.11, that's going to be our standard deviation. And you know, obviously, we don't have to enter these things in order. The next thing that I'm going to get from my output, and something else, let's go down to the bottom. Let's always talk about our sample size. So our sample size is equal to 20, and of course we get that from here. So let's scroll on down, and we will get our other information. So it looks like Q1 is 16.30. Looks like Q3 is 24.65. I don't know much about body fat numbers. I know that I run a lot and I lift a lot. And every time I go have a body fat, they make me feel like I'm the most obese person that ever walked the planet of this earth. And I don't know. I don't seem to think I am. But well, my dogs. I live on a lake, and the dogs, they're not my dogs, are chasing some geese, and the geese aren't real happy with that. So sorry. Gang. Something else we can get from here is the median, which is 21.20. And again, that comes from this MED. And, the rest of the stuff, I'm going to have to use my calculator to find it. So, and I'll show you about the mode here in just a second, the easiest way to take care of the mode. So, guys, for the range, I need to take 27.2 minus 11.7. Now, some of you can do that mentally, but if you can't, it's not a big deal. Just use your, so 27.2 minus 11.7. So guys, the range is the high minus the low, so our range is going to be 15.5. So well, I'll go through it in a minute and tell you what all these mean. The IQR is just Q3. Minus Q1. So 8.35 is the IQR. And the rest of this stuff we're going to, well, I'll tell you what, let's go ahead and do the variance. The variance is the standard deviation squared. So that's the way we do an exponent, okay? So the variance is 26.11. Now these are the sample variance and the sample standard deviation. We talked a little bit about the population before, and guys, let me just go ahead and show you. Your calculator gives you the population standard deviation. We typically don't use that because if you think about the way I started this video, I'm assuming that we pulled a sample of like body fat. I think I mentioned ACT. We're pulling a sample out. So we don't have a population, but if you did want the population standard deviation, this is this one right here that says sigma x. So it would be 4.98. The sample the population standard deviation is always less than the sample standard deviation because of the denominator. We divide by a bigger number. We divide by n instead of n minus 1, as I demonstrated in a previous video. So if we wanted the population variance, we would take 4.98 squared to get it. The population standard deviation is 4.98. The sample standard deviation is 5.11. That's the one we typically report because we're typically describing, statistically describing a sample. Okay, now the mode, a kind of a cool way to do this, you know, when I go back here and just look at my data set, it's really hard to see if there's any repeated data. So let me get this down and let me make this larger where we can show some stuff. It's kind of hard for me to look down through here and see if there's any repeated data, but there's a function on your calculator that makes this kind of cool. If you go to Stat and go to Sort A, that's going to be sort ascending. So that's going to start from the lowest number to the highest number and put these things in order, so it's going to make it easier to examine if there's any repeated information. So I'm going to go sort A, and I want to sort my list L1. And then it'll say done. So now when we go back to our data set, S's are giving me a problem today. I can go down through here and see if there's any repeated data. And I thought there was, but there's not. Okay, let's go on and see if anything's repeated. Usually when we have information that's presented as decimals, we don't have repeated data. Okay, so there is a 25.4 is actually repeated 3 times. Well, for some reason my calculator has stopped. It has completely locked up. Don't know what's going on there. But we'll try to get that back. Okay. So guys, it looks like the mode is going to be 25.4 because it occurred 3 times. You guys, let me see if I can get this calculator unstuck. Well, shoot. Not cool. Daggone it. Let's see if we can save a calculator file. I really don't want to type this stuff in again, but I also don't want to crash my computer. Shoot. All right. It looks like I'm just going to have to do a force quit on this calculator. It doesn't look like it's. Doesn't look like it's wanting to respond. Well, we'll go back. I'll have to go back in and type the data back in. But let's do that in just a second. Okay. All right, gang. We found our information here, and let's as a review from what we talked about in the previous video, let's go through and talk about each one of these. What does this 20.20 tell us? Well, that's just the arithmetic average. The median, 21.20. Remember, when we talk about location in a data set, we typically define that as the percentage below. I don't know why statisticians are obsessed with percent below, because a percent above is just as valid, but we talk about percent below. So what we would say here is approximately 50% of the body fat measurements are at or below 21.20. The mode of 25.4 is the value that occurs the most. I think my calculator locked up and I didn't get to go ahead and look at the bottom, but I think that's true, and I'm going to assume it is. The range is 15.50. That's the difference in the highest body fat score and the lowest body fat score. Q1 is 16.30. We would say approximately 25% of our body fat scores are at or below 16.30. Q3, approximately 75% of our body fat scores are at or below 24.65. Guys, this is the kind of stuff that I expect you to put in your video notebook. Video notebook is kind of my way of saying, if you show up for class, watch the videos, I'm going to give you some extra points. That's what that essentially stands for, or what what its purpose is. IQR is 8.35. This tells you that the range of the middle 50% of our data, the range of the middle 50% of our body fat scores is 8.35. Standard deviation, what I want you to know here, this is a measure of spread centered around the mean. Centered around the mean. Guys, quartiles are a measure of spread centered around the median. Standard deviation and variance are measures of spread centered around the mean. So we'll talk about that more here in probably about the next minute. So these two again, 5.11 and 26.11, are measures of spread that are centered around the mean. And of course, n is just our sample size. That's how many body fat measurements that we collected to analyze. Okay, so one thing I want you to take away from this is we have measures of center and we have measures of spread. Okay? When we report or focus on the mean as a measure of center, the standard deviation is going to be the corresponding measure of spread that we will focus on. If we focus on the median as the measure of center, then quartiles, Q1, Q3, and or the IQR are going to be the measures of spread that we're going to focus on. Now, question should be, when do we refer to the mean or the median? Which one, because, guys, I don't want any confusion here. If I were going to let's say I had these body fat scores and I was working with a doctoral student or master's thesis or even an undergrad student, and we were going to summarize these body fat scores, we'd report all this. I'd report the mean, the median, the quartiles, the standard deviation, sample size, and some skewness and kurtosis and different things you won't learn in this class. But if I'm really trying to determine the best measure of center, Is the best measure of center the mean? If so, the standard deviation is the best measure of spread. Or is the best measure of center the median? If so, the best measure of spread are the quartiles or the IQR. Well, the question comes up, well, which is best? And what we do here to make this determination is we examine what's called a histogram. Now, what a histogram does, I got to tell you, I posted a video of my daughter. Both my daughters graduated 5th grade today. I don't know whether I've told you guys this in a previous video or not, but my wife and I adopted 2 little girls from China. Sadie was adopted in 2005 and Bailey was adopted in 2006. Well, Bailey has always been really, really, really quiet. And she just long story short, she has really come out of her shell. I'll tell you what, I'll just show you a treat. All right, let's see if I can bring this up. So I posted a video of her on Facebook. Hopefully nothing comes up that'll get me in trouble. So watch this. I don't know whether you'll be able to hear it or not. Okay, sorry. But girl cracks me up. What makes that so special is she was so incredibly quiet and shy when we first brought her back from China, which is 2006, so 9 years ago. And through the 9 years, seeing her transition into this, confident, extremely smart. The bad thing I can't even take credit for because I didn't make her, but this incredibly just popular, smart, outgoing little girl. It's been really super cool. So guys, I'll do stuff like that from time to time. I know statistics can get really dry, and plus it keeps me kind of from getting too dry. So what I would do with a histogram, if I'm going to make a histogram, I'm going to create classes. And guys, I would never, ever, ever create a histogram by hand. I would use the calculator or R, which I'm going to show you how to do. But I just want to kind of run through this with you to give you an indication of how these things are created. So when you see a picture of them with your calculator, you'll have some kind of clue what's really going on here. Now, I'm going to have to bring this calculator back up, and I just hope this thing doesn't go crazy on me and lock up again, because that's really uncool. And if it does, I'll just start using the other calculator. Now, more than likely, I've lost my values, so I bet you anything I did. Darn it, darn it, darn it. Okay. Shoot. All right. Well, that's just the way it goes, I guess. There's not much I can do about that. Let me get these over here and just do some typing. Okay, darn it. All right, so 11.9, 22.8. You guys will probably want to fast forward this. Sorry. 18.7, 20.1, 12.9, 21.7, 27.1, 25.4, 21.3, 19.3, 25.4, 27.2. This is boring. It's Don't like this. Have no choice. You love it when your professor talks to himself. 12.8. Oh, guys, I will tell you one thing. I usually tell this to my classes the first day. I've got a couple of emails from you guys. I hate being called Mr. Darborough. I mean, I really do. I probably need to go on the Dr. Phil show and have this worked out. But when somebody talks about Dr. or Mr. Darborough, it seems like that's more appropriate for my dad. So, guys, call me Doug. Dr. Darborough, Professor Darborough's okay. I don't really like that as much, but Doug's fine, Dr. Darborough, whatever. But Mr. Darborough just kind of ekes me out. So, all right, gang. So I've got the information in. So let's get rid of that and let's make this bigger where you guys can see it. All right. So what I want to do here is I want to go through this whole sort ascending thing again and make sure that 25.4 was indeed my mode. It'd be kind of embarrassing if I found out that it wasn't. And it turns out that it is. Okay, cool. Now, so what I've got here is if I'm going to determine my classes, I want my lowest number and my highest number. Well, my highest is 27.2. And so 11.7, and I'm writing this so I don't forget it. 27.2. All right, let's get out of this. All right, so what I want there, to create my classes, what I would do is I would take my high minus my low divided by 7. Okay, so when I do that, I have 27.2. Make sure you put this in parentheses. Now, you're probably thinking, well, why 7? What's so holy about 7? What you can find out is when you create these histograms, it seems like 7 classes seem to turn out the best. And I put best in parentheses. So I get 7.75. And I would just round this to 8. So what I would do here is I would create a frequency distribution of classes. And my classes would be, I would start it somewhere below the lowest, so I would probably start this at 11. My class width is 8, because I want to divide the difference between the highest and the lowest by 7, so I can get approximately 7 to 8 bars, because that creates a histogram that does what I want it to do. And I can accomplish that by having my class width is 8. So if I run this to 8, that's going to run up to 19. I'll start my next one at 20, run it up to 28. Start my next one at 29. Run this up to 37. Go my next one at 38. Run it up to 46. Guys, I don't like the way this is going. You just got to see what I did. You guys are probably sitting there screaming at me. It's not working out right. Why did you change the 7 to a 2? Well, I had a bozo moment. Sorry about that. First mistake I've ever made, and it was captured on screen. So if we divide by 7, we get 2.2, like we should. Okay, I would probably just round this to a 2. Guys, I'm just illustrating this. I would never, ever, ever do a frequency distribution by hand. So guys, let's do this the correct way now. After we divide by, why not we, me. So I have classes and frequencies, so I would go below the lowest. My class is 2, so I go up to 13. I would start the next one at 14, go up to 16, next one to 17, go up to 19, the next one to 20, and I think you see what's going to happen here. The next thing I would do is I would go to my data set and I would see, well, how many entries do I have between 11 and 13? And it looks like between 11 and 13 I have 4. So I'm going to write a 4 there. Between 14 and 16 it looks like I have 1. Between 17 and 19 I have 2, and so on and so forth. Okay. Now, in drawing a histogram, again, I would never draw all these by hand. I'm teaching. Okay. What I would do here, a histogram starts with frequencies. So I would plot the frequencies on the vertical axis. And on the horizontal axis, I would start with, since we're breaking up the scale, I would come in and break that up accordingly. And I would start here with an 11. The next thing I would put is a 14. And I would put a 17. And I would put all of the left endpoints on the horizontal axis. So between 11 and up to 14, I would bring the height of the bar up to a 4. Again, I would never do one of these by hand because I'm not neat enough. Come up by 1, and this one will come up by 2. Now, go ahead and continue that, and what you would do is you would have a histogram. Now, you probably zoned out on me because that was extremely boring, but what I'm getting ready to tell you is not extreme. Well, it may be boring, but it's extremely important. What we want to be able to do in statistically describing our sample measures. And guys, in this illustration, this is for our body fat measurements, okay? First thing we want to be able to do is we want to be able to report the numerical summaries. And guys, there we want to be able to make a center statement, and we want to be able to make a spread statement, okay? The second thing we want to do is we want to be able to report the shape of the distribution. This comes from a histogram. Now, let me explain to you what we're going to run into. And guys, finally, we want to be able to determine outliers. And to determine outliers, we will create what's called a box plot. Okay, and I'll show you how to do that in just a second. There's lots of different distribution shapes, but for this class, there's only 3. Distribution shapes that I'm going to hold you accountable for. The first one is something that looks like this. We will call this bell-shaped and symmetric. Now, you might be saying, Doug, Dr. Darbro, whatever, just not Mr. Darbro, right? You might say, well, this is not really bell-shaped because it's not, but it's kind of. And it's not really symmetric, and I'll tell you, well, it's not, but it's sort of approximately bell-shaped and symmetric. We're not taking this literally yet. Now, here in a couple of weeks, we're going to take it literally when we get into a distribution called a normal distribution that describes a population. These things refer to samples. So if we go out and collect information from a sample and we create a histogram and it looks something like this, we're going to refer to this as bell-shaped and symmetric. Sometimes we run into histograms that under no stretch of the imagination look bell-shaped and symmetric. If we have something like this, we're going to call this positively skewed. Another distribution shape that we run into in this class is something that looks like this. What do you think that we call this distribution? We call this negatively skewed. Now, we can kind of smooth these things out. To give us distribution shape, sometimes we just see the smoothed out curve, and that's going to happen a lot, especially here within the next couple of weeks. But what we want to do, and our goal in describing our sample, is to create a histogram of our data and see which one of these three it looks the most like. What characteristic? It's never going to look like exactly this one, or exactly this one. But which one does it look the most like? Well, guys, once we got our data entered into our calculator, the rest is pretty easy. We can get a histogram very, very, very quickly. So I want to go second, and I want to go up to this key that says stat plot. Now, the very first thing I want you to do is make sure that you have all of these things turned off. And because if you have, we're ultimately going to turn number 1 on. So if you look down and number 2 is off and number 3 is off, then you're fine. But if you have number 2 on or number 3 on, we need to turn those off so they don't interfere with what we're trying to do in plot 1. So I would go ahead and just turn them all off. So I would hit number 4, just hit the key 4, hit enter, and done. So that's turned all the plots off. So we're all starting with a kind of a clean slate. So second function, stat plot. I want to deal with the first one. So the first thing I got to do is turn it on. It's kind of weird I turned it off, but I turned it off because I wanted to make sure all the other ones were off. So I'm going to hit enter to turn that off. Then I'm going to hit my down arrow. I'm going to scroll over to my histogram, and I'm going to hit enter to select it. And I will come down to my list L1 and my frequency 1. So guys, take a deep breath. Make sure you've accomplished the following. Make sure that your on is selected. Make sure your histogram is selected. Make sure L1 has been selected, and make sure your frequency is equal to 1. Now, let's say something with your calculator. Let's say you have an L2 there, and you come down to L2 and you try to change it to a 1 and it gives you a Y. That can be really, really, really frustrating. For some reason, when it gets down to here, if this is anything other than 1, it will lock the alpha. So you have to unlock the alpha by hitting the alpha key and then hit the 1 to create a 1 there. Now guys, if you got anything wrong, if you don't have it turned on, if you don't have the histogram, if L1 isn't there, and if 1 isn't there, it's not going to work its way out. You're going to get an error, and it's going to be frustrating. And in a sense, you deserve the frustration because you didn't follow directions. On, histogram, L1, 1. If you got all that set, life is going to be good. Now, what happens right now is your calculator, if I can go back to this, your calculator already has this histogram drawn. But right now, it is looking and your histogram somewhere right there. Well, wouldn't it be really nice if we could ignore the domain from negative infinity to positive infinity on both and just tap into that small part of the graph that we want to look at that gives us the best picture? Well, it turns out, and by the way, the answer to that is yes. it turns out there's a way that we can do that. So once you get this set, just go up and go zoom, scroll all the way down to number 9, or just hit the 9 key. Now from here on out, I'm going to hit zoom 9. But since I'm teaching, I'm going to scroll down just to show you what's at zoom 9. Zoom 9 is zoom stat. So anytime we have a stat plot that we're executing, zoom stat gives us the best picture. So now I just hit enter, and you'll see that we get a histogram. Now I'm going to look at that, and I'm going to go back to, and you can still see it right here. I'm going to go back to my 3 drawings and look at this right here and see which one of these 3 it looks the most like. Well, guys, I'm going with bell-shaped and symmetric. Okay? So, guys, the third thing I wanted to accomplish was the distribution shape. So I'm going to say the distribution shape here is bell-shaped and symmetric. Is it perfectly symmetric? No, it's not. It's not about that. Is it bell-shaped? No, it's not. This first bar right here, you know, is well, it's just not bell-shaped and symmetric. It's not about that. It's whether it's approximately bell-shaped and symmetric, or is it approximately positively skewed, approximately negatively skewed. And this one looks more bell-shaped and symmetric than it does the others. Now, the next thing we want to do is we want to take a look at our outliers. Now, let me show you what we do here. To identify outliers, what we do, let's see, I don't know how far am I into this video. What time is it? I don't want this thing to go too crazy. I can get more scientific. So I'm into this thing about an hour. Guys, I'll tell you what. I see that my battery's about to go down. Hold on just a second. I want to go get the charger. All right, guys, sorry about that. I saw up here in the right-hand screen, I see that, oh, it's my dad's birthday. I just noticed that too. Up here in the screen, I only had 5%, so I didn't want my computer to crash on us. Guys, outliers, you know, I'm into this thing almost an hour. I'm going to go ahead and just show you how to find these, and we'll worry about defining them later. I'll do that in the next video. Well, guys, outliers are determined by box plots. So, if there are actually 2 types of box plots, and these things come from the 5-number summary. So they include the numbers, the min value, Q1, the median, Q3, and the max value. They don't, standard deviation and the mean aren't involved in creating a 5-number summary. I'm sorry, in creating a box plot. The sole purpose of a box plot: identify outliers. Sole purpose. They give us a picture. They're going to tell us more than just outliers, but the sole purpose in this class of creating a box plot is to identify outliers. It turns out these things are really easy to create with your calculator. You go up to the same stat plot. We've got 2 and 3 turned off now, or at least we should. Make sure it's turned on. Now, if you come down, you're going to see that, I'm going to circle it with my mouse, you have 2 box plots. You have the one right here with these dots. This is a box plot with outliers. And right here you've got a box plot without dots. This is a box plot without outliers. So guys, we're always going to want the one with outliers. So I'm going to go there and I'm going to select it. I'm going to come down to L1. Frequency is 1, and the mark at the bottom is how your outlier will be displayed if there are outliers. Okay? So again, I'm going to go zoom 9. And I look at this box plot, and there are no dots. So I would say we have no outliers. Now, let me show you the way that outliers are. I wasn't going to do this, but actually I am. Let me show you the way that outliers are actually determined and identified. If you take, if you look at the, you've got your data range from low to high. And we come in and we define the median. Well, we can do something called an upper fence. Then we can do something called a lower fence. The upper fence is the median plus 1.5 times the IQR. The lower fence is the median minus 1.5 times the IQR. Now guys, we saw earlier that the median score was something. I think I've still got that someplace. No, I wrote that down. Okay, here we go. The median is equal to 21.20. And our lowest score was 11.7, and our high was 27.2. Okay, now to determine if we have any outliers, we're going to create what I call these fences. And these fences are these segments, if you will, that are built around the median. So the upper fence is going to be the median plus 1.5. We saw earlier that the IQR was 8.35. The lower fence is going to be 21.20 minus 1.5 times the IQR. Now let's go ahead and get our calculator and put those in. So if I take 21.20 plus 1.5 times 8.35, I get 33.73. My lower fence is 8.68. So guys, if I have any value below 8.68, this is called an outlier. It would be a low outlier. If I have any value above 33.73, this is referred to as a high outlier. Well, guys, you can see the reason we didn't have any outliers is our largest value is 27.2, which is within the bounds of the 33.7, and our lowest value is 11.7, which is above the lowest, kind of the cutoff for being an outlier. So guys, according to this method right here, anything 8.68 and higher up to 33.73 defines the segment that is not an outlier. Anything, again, above or below is determined to be an outlier. Okay? Guys, I think I've done enough damage to you. This is kind of a long video, but, you know, you got to think that typically in this class we would have spent 4 hours. Well, usually about 3.5 hours. So, plus, you know, hey, you don't have to drive. So guys, that's it. I'm going to end this video. All right, take care.